In this video, we're going to be talking about graphing quadratics by transformation. Now, if you haven't done it already, you should make sure that you do the investigation part of this lesson first. So stop the video, do the investigation, and then restart it once you're ready. We're going to talk about graphing quadratics by transformation. When we're graphing by transformation, it's different than graphing by intercepts. When we graph by intercepts, we use the x-intercept, the y-intercept, and the vertex to help us figure out where the graph is. When we're graphing by transformation, we take a basic parabola and then move it around, up, down, left, right. We stretch it, we compress it, we turn it upside down. So hopefully you finished the investigation and you looked at the variety of graphs that were given to you, and you were meant to figure out what you thought the different letters in this equation do. So y is just y, the x is x, the square is what makes it a parabola, but the a, the h, and the k are the different things that help move our parabola and change its shape. So the number at the end, the k, that's what the first example was all about. And hopefully you figured out that this is what moves our parabola up and down. A positive number like +3 is what would make it move up. And a negative number like -3 is what would make it move down. Now the official math name for these things are vertical translations. But up and down are just fine. Up next we have the h inside our bracket, and if you did the investigation, hopefully you noticed that putting a number inside the bracket is what moves the function left and right. So this one's a little trickier. It makes sense to me that a positive would move up and a negative would move down, but when I look at these, I think that a negative should move to the left into the negatives, and a positive should move to the right into the positives, but it's actually the opposite of what you might think. So in our equation here, the h moves our function either left or right. Put a little arrow in there. So something that would make it move to the left would be a positive, and the type of number that would make it move to the right would be a negative. Our last letter is the A, and that's when we put a number in front. So if we take a look at the examples from the investigation, this didn't move it up or down, left or right, it just changed the shape. It made it thinner or wider, or sometimes flips it upside down. So these things are called stretches, where it makes them thinner, compressions, where it makes them wider, and reflections when they're upside down. And the type of things that make stretches are numbers bigger than 1, like 2, 3, 4, 5, 6. Things that make compressions are numbers between 0 and 1, so usually fractions and decimals. And things that make a reflection are negatives. So this can be a stretch, compression, or a reflection. Things that make a stretch are numbers that are bigger than 1. A compression would be something between 0 and 1, so I'm just going to say less than 1. And a reflection is going to be a negative. So we're going to try putting these into action. We're going to take a look at our first question, which says state the transformations on each of the following. So we have y equals 8 times x minus 4 squared minus 9. And I'm going to identify what each of those three numbers does in the function. I always like to start at the end, find those ones easier. The minus 9 is going to move it down 9. Inside the bracket, the minus 4, I would think would go left 4, but it actually goes to the right 4. And the 8 out in front would be a stretch, since it's bigger than 1, of 8. That means that it's 8 times taller or 8 times thinner than a regular parabola. If I take a look at the second example, we have y equals -1/2 x plus 7 squared plus 30. And I'm also going to start at this end. The plus 30 is going to make it go up 30. The plus 7 inside the bracket doesn't go right 7, it goes left 7. And up front, we actually have two things going on here with the a. We have a negative and a fraction. So the negative part is going to be a reflection, which means our parabola is going to be upside down. And the 1/2 is going to be a compression. And I prefer not to say a compression of a half, but a compression of 2, since it's going to be 2 times wider than the original parabola. All right, so let's take what we've done with our transformations and see if we can actually find a way to graph using that information. So we have the function y equals -2 times x minus 3 squared plus 5. So the first thing I recommend you do is to list your transformations, identify what's going on with the graph. So the plus 5 means we're going up 5. The minus 3 is going right 3. That 2 is going to be a stretch of 2. And that negative is a reflection. Now if I flip back to that investigation and I take a look, we're just going to zoom in a little here, at the parabola y equals x squared. A basic parabola y equals x squared has its vertex at 0, 0. And then to get to the next point, there's actually an interesting little pattern. To get to the next one, if I go up 1 and over 1, I end up at the next point. And if I go over 1 and up 1, 2, 3, the next point, and then over 1 and 1, 2, 3, 4, 5, I end up going up 1, 3, and 5, which are all odd numbers. And the pattern actually continues. It's going to go up 1, then 3, then 5, then 7, then 9, and it just keeps going. So when I'm graphing by transformation, I need to think about that basic parabola, which normally starts at 0, 0. So I start by thinking about the vertex. Instead of starting at 0, 0, we're going to go right 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5, and that's my vertex. So the vertex of our parabola is actually going to be 3 and 5. Now from there, we're going to use what we call the step pattern to help us find the remainder of the points. So a regular parabola goes up 1, then 3, then 5, then 7, then 9, and it continues, but we definitely won't be able to fit it on a grid this size. My graph is being reflected, so flipped upside down, and stretched by 2. So to stretch it by 2, what I'm going to do is take all of these numbers in my step pattern and multiply them by 2. And to do the reflection at the same time, we actually are just going to multiply it by -2. So I do 1 times -2 is -2, 3 times -2 is -6, 5 times -2 is -10, 7 times -2 is -14, and 9 times -2 is -18. So from my original point, we're always going to move over 1, and I'm going to go down 2, and then over 1 and down 6, over 1 and down 10, which I don't believe fits on the graph. It would be somewhere down off the grid. And then we do the same thing on the other side, over 1 and down 2, over 1 and down 6, and then over 1 and down 10. And then all we need to do is connect up our points. I'm better at drawing parabolas if I do this the other way. Make sure you draw it all the way to the end of the grid and put arrows on the end. Try to make sure it looks at least like a curve and not just a pointy line. Okay, so some things we want to label on our graph. The first one is our vertex, which we've already done. We said that was at 3 and 5. The next one is the axis of symmetry that we've talked about already. So the axis of symmetry is that line that cuts the parabola into two mirror images, which would be that little line right there. So that would be at x equals 3. It always matches the x part of your vertex. All right, maximum value, this has a maximum. And the maximum happens to be 5. For the domain of my parabola is always going to be from negative infinity to positive infinity, since it just keeps getting wider and wider and wider and doesn't stop. So I write XER, and that we go from negative infinity to positive infinity, and x is all the values in between. Our arrows on our greater than and less than sign should always point towards the smaller number, and negative infinity is definitely smaller than positive infinity. You can put the equal signs on, although you can't really get to infinity. And that's my domain. Now for the range, we're going to look at our lowest possible value, which would be down here at infinity, and our highest possible value, which would be 5. So I'm going to say that it's YER, and then we're looking at all the numbers between negative infinity and 5. And y is in between, and the arrow should point towards the smaller number, which would be the negative infinity.